Hey guys, I'm going to post up a video here, a little in-depth video of using the RapidChange ATC along with the new FluidNC 3.9.7 and how to set it up and a couple things that you need to do when doing so. This is the new portal page. Don over at RapidChange ATC should have sent you your profile, and this page is where you're going to set everything up. Prior to doing that, you're going to want to have your machine up and going, and go in and make sure you download all of your previous config files, the one that you're using now on 371 or 373, and go ahead and download those to back them up to your computer. The main one, the YAML file, is the most important, and you're going to want to do a clean install of the new Fluid. So once you have that, make sure you remember your Wi-Fi settings if you have it on static or such, and from there you'll go to the page right here, and inside of Fluid itself you're going to hit the connect button, and the connect button is going to link you up to your board. I'm using a PyBot version 4 board, and it should connect you up, establish the connection to get the new 3.9.7. Once it comes up, you'll see that it's got upgrade Wi-Fi settings. You're going to want to go ahead and click on the install ESP32, and your Wi-Fi settings are going to be off to the right. You install it as normal. It'll go through, do its little thing. I already installed it, so I don't need to. Once you finish with that, make sure your client station is set back up to fallback default, and put your new Wi-Fi info in there, and you should be set up. And choose the Wi-Fi, support Wi-Fi and WebUI. And don't worry about the Bluetooth or non-radio. And that's all you really have to do for that. I'll go back to the other page here. Now, the downloaded files that you saved as a backup, your YAML file, on the left here is my original, and on the right is the changes that need to be made in the YAML file for the new 397 to work with the ATC. You have to delete everything that you see from the dust cover, tool recognition, all this right here, all the way up RapidChange needs to be deleted. If you see on the right underneath my spindle, if you're using a Wanyang spindle or a 10 volt, you'll have your information here, the UART. The info that needs to be added is right here, the M6 macro, and this tells it to run the tool changing NC macro that Don has created. The two other portions, the user output and the user inputs, are what the actual dust cover and tool recognition. As you can see, the dust cover pin here is 13. That has to go on an output, and I put it in here. And the tool recognition goes into the digital 1 input. Once you have that set up and it has to be orientated right, you should be able to connect to your machine and everything be normal, come up like normal, like it did in the past. We'll go back to here. Now from here, back on the portal, if you go to your dashboard, if you haven't created one, it'll ask you to add a new profile, and my profile is already set in here. As you can see, I have my X, Y positions, Z positions. The first thing you want to do is set up your magazine layout. Make sure it's set to how you have it orientated on your machine. Mine's on the left of my machine, lengthwise. The pockets are actually in the Y-axis. They go positive, and the setting for that, they're 45 millimeters apart from each other. The first one that you need to set, if you get it from your previous YAML file, mine's a little different here. I think this is an older one, but mine are 6.4 on the X and the 149.6. The first settings you put in here, you just change the first one. It'll make the additions and changes to the others. The Z position, how that's calculated is it's a difference from the tool. If you go into edit Z positions over here by clicking the little gear, edit Z position offsets, this will bring up a window. The zone 1 and zone 2, where the eye are infrared, they've set it up to where the machine automatically knows the differences of the two, where the Z offset engages and the actual Z height, it subtracts them. So if you were to subtract 42 from my 69, which I have there, it would be, let's see, we'll do 42 minus, it's 27. So my engage is actually 27. And you won't see that number anywhere in here. How you get that is by running the Z tool. And I'll show you in the macros here. Once you set this all up, make sure your numbers are in here. Put your clearances, your feed rates, your tool position for your tool setter, and any of the other information you need in here. This is going to generate your tool change NC file, the tool measure, the find Z position. The find Z position is the one for the infrared beam to tell where it is. You can download these all and put them in a safe location that you have on your computer. And then once you do that, you're going to want to go and load them onto your SD card. Your SD card, as you can see, I have the tool change NC, the find Z position, which is right here, and I'll show you what the actual find Z position actually does. Right here, here's a picture right here of the ATC find Z position. When you click this find Z position right here, it's going to go ahead and, let me get there we go. All right, there we go. It's going to go ahead and you basically put your tool and collet to the just below the edge of the tool changer, and then run the find Z position NC, and the find Z position NC will run and raise the bit until the IR sensor disengages, and once it disengages it, it will spit out a number, and the number will be recorded in the console. See, this one I have my spindle over the second one, and the coordinates you can get from the web UI. As you can see here, as it's raising up, It'll stop once the beam is struck, or the beam actually breaks the collet. And on the right hand side in the console, it's going to spit out a number to you. That's the actual number. Let's see if I can show it. I was zooming in here. Mine is set to 67. 67.200. You can see that right here. And that's the number that you're going to want to put in to your Z position. So let's pause that, close that down, and we'll go back over to the FluidNC page here. Mine's set to 69. And if you'll notice on the right, you got zone 1 and zone 2. These aren't editable. The only thing that's editable in these is the actual output pin. And these are a reference, the dust cover P0 and P1, to the input outputs that are in the YAML file. So my 69 or 67 is actually in between these two numbers and a reference from this. So if I go over to the edit Z offsets, 42 is going to be my engage because it's a subtraction of the Z position and the infrared here. And that's how it ends up calculating that. And usually once it's set, it's a lot easier than it was in the past to set it up. You can fine tune it pretty easy, but that's all you have to do with that portion of setting up the Z. Now from there, we're going to go ahead and go back to FluidNC. Now the TC file that I put in here, this is the file that is used to control the ATC. The new command that they use for the ATC to query a tool, like right now if I were to hit $G, it's going to show that I have no tool loaded right here. To change that, I would just hit the M61 like previous. M61, and now I'm going to enter a Q number. So Q1 would be tool 1. And as you can see, the tool 1 is try to load a tool that is not in the number of pockets you have. Like I only have 6, so if I were to enter M61 tool 7, it's going to do a manual tool change. And how the manual is set up is the location that you have on your little web UI here for manual position. I have mine set to the front middle of my machine, 200 by 50, and that's where it'll go. If it receives an error for some reason, loading, unloading, or something like that, the IR sensor isn't tripped, it will return to this position and give you a little prompt so that you can either continue by hitting the play button to measure the tool or correct it or such. And that's basically how that works. Everything else is pretty much the same. The program does work. You can connect your machine if you don't have the WebUI loaded. I use OpenBuild's control. I've used that before for running the machine. I also use Universal G-Code Sender for certain things. Universal G-Code Sender allows you to probe hole centers and find the center position of a hole. It has surface scanning, which means if you wanted to probe 9 different points on the top of a workpiece and get those calculations, you can do that. So you can use different applications, and those are usually connected. You can connect some of them through Wi-Fi. Um, I usually connect them through USB, but that's your choice. Um, Everything else up to that point works great, um, for the machine, for the tool changes. I hope this video helps anybody that had any questions about how to set it up, or the things that might cause questions as far as the Z position, where this comes from, and the offsets for this. So we'll see you in the next video. Thanks.